Hello everyone, this is Sandeep Dikshit here, and I've completed MSc in Physics, and I'm teaching physics to all boards, state board, CBSE, ICSE, IGCSE, and IE. So in this module, we're going to learn about the gravitational force and universal law of gravitation. So let's move our new topic. So today we're going to learn a very interesting and a very fun topic, and it's all about the gravitation. Have you ever wondered? Uh, so here is the picture. Have you ever wondered why things fall towards the earth? Yes. So each and everything falls towards the earth with gravitational acceleration. Yes. So gravitational forces are the forces of attraction. Yes. It's like Earth's pulling on you towards it and keeping on the ground. Yes. Okay. Keeping so take an example. An object is thrown to upward. Okay, but it accelerates. But object accelerates and force towards the earth. In physics, in physics, an object brings down towards the earth is known as the gravitational forces. But what is the gravitational force? So gravitational force is a force that attracts any two objects with mass. We call the gravitational force attractive force. It always tries to pull masses together. It never pushes them apart. That means it should be have a mass. Okay. So now let's move ahead. So let me ask you one simple question. Have you ever wondered what the origin of gravitation force is? In front of you, all the energies are there. Okay, so well, technically, there is no scientist and physicist that can describe the origin or any other natural forces. But different hypotheses among all rules or laws, the most prominent theory was given by Isaac Newton. And this all started with an apple. That's right. Yes. Okay, so the legend was sitting under the tree, an apple tree. Suddenly, an apple falls on his head. He started thinking, why the apple falls vertically downward? Why not upward? Why not horizontal? And this was the aha moment for the Newton. As and he and like him to come up with the yes, the law of with the gravity. Yes, that's right. And he knew that yes, this is the gravity. Yes. Okay. So Newton first published a principle in 1687, and this principle states every particle attracts every other particle in the universe with force directly proportional to the product of the masses and inversely proportional to the square of the distance between them. And this is called the universal law of gravitation. Newton's universal law of gravitation. That means the object should have the mass, and if the massless object is there, yeah, then yes, the universal law is not applicable for them. So here, this makes give equation to be here the two masses. Okay, so the two masses are there, m1 and m2. In between, the distance is there. Okay, so it gives the equation F is equals to G m1 into m2 upon d square. But how is it possible here? As you can see here, the force is directly proportional to the product of the masses and inversely proportional to the distance square. Okay, so here comes so proportionality. As the proportionality changes into the equality, so we have to use the constant term, and that is G. Gravitation is constant, and hence it gives the equation F is equals to G m1 into m2 upon d square. Yes. Okay. So here it gives the scientist. Okay. So here it is the scientist, that is Newton. But as you can see, this is but note that Newton had no idea what is the value of G. He thought that he assumed that the value of G must be some in a tiny particle. That means it should be as a tiny. Yes. Okay. So that's here. But have you how do we come to know that the law of universal gravitation made by Isaac Newton is true? Yes, that's right. Okay, so here the another British scientist who also had researched who also had researched on the gravitation, and he found successfully, okay, and he found successfully the value of the G, that is 6.67 into 10 raised to minus 11 Newton meter square per kg square. Here with meter should be square is there. Okay, so Newton meter square per kg square and should be square. So he figured out this. Okay, well, before we move ahead, okay, so yes, Newton also, yeah, perhaps I'm right. So before we move ahead, okay, do you know when both ball and feather drop, okay, simultaneously to the ground? So who drops faster? Okay, so when ball and feather fall simultaneously, okay, so with at the vacuum state, both drops simultaneously. That means both touches the ground at same time. But when at the air resistance, the ball moves at same speed, but the feather starts to blowing in the air, so it drops very slowly. Okay, so but when neglecting the air resistance, the feather and the ball drops same time and touches the ground. Okay, so yeah, so this much is in this module. Okay, so thank you very much, and God bless.